Section 11.6, segment relationships in circles. So, continuing our tour de force of all things circle related, with angles, with segments and lines. The chord-chord product theorem. If two chords intersect in a circle, then the part of one multiplied equal the part of the other multiplied. So chord AB split up, those parts AEB, EB multiplied equal chord CD split up, those parts multiplied, CE and ED. So we're going to look at example 1 here. Two chords intersecting, so the parts multiplied equal each other. So 14 times X, the parts of chord GH, equal 7 times 10, the part of FE. So multiplied together, 14x equals 70. Divide by 14, x equals 5. Then be careful, please answer the question being asked. Find the length of each chord after you find x. So you have x. Finding the length of each chord, we have GH. That is 14 plus x, which is 5. So 19. We have FE. 7 plus 10 to give us 17. So we have our three answers. These chords won't necessarily be congruent, so you're not looking for that relationship. Alright? A secant segment is the segment with the secant of a segment with at least one input in the circle. So remember, every secant has a chord. We're looking at secant segments, kind of the same idea, okay? So a secant segment is a segment of a secant with at least one input. Okay, at least one. So to keep it simple here, we'll say segment PN and segment KJ. Let me check, see if I missed anything. I don't think I did, but let me be sure. Okay, good deal. To find external secant segments, those are parts of the secant that are exterior to the circle. One endpoint should be on the circle. So I'm looking at NM and JM. Alright? The secant product theorem. Okay, kind of look at how I color this. AE times BE. So AE is the whole thing. BE is only the exterior. Same here. CE and DE. CE, the whole thing. DE, only the exterior. Okay, so be careful when you're setting this up, that you're setting up with the correct length. So find the value of x and then the length of each secant segment. So we want GE, the whole thing, x plus 8 times only the exterior, equaling DE, the whole thing, so 9 and 7. don't multiply, have a lot of students want to say over here 8x. And then here they add, so make sure you add both times. Alright, then go ahead, solve that. Make sure you answer the question that's being asked. A tangent segment is the segment of a tangent with one input on the circle. So for example, AB I can hear my kids playing. I think they're trying to be Bowser from Mario. So they're trying to be big and mean. But they're 6 and 4, so they're not. But their vocals, it's cute. Okay. The secant tangent product theorem is pretty much like the secant product theorem. You have AC, the whole thing, times BC, the external part. And then you have DC squared, so DC times DC. Well, DC is the whole thing. DC is also the exterior. So it kind of fits that secant product theorem. Alright, take a look at the example 4. Check your work with my complete notes online.